In this video, I'm going to look at the algebra of functions. So we're going to add, subtract, multiply, and divide them, and then also look at composite functions. Okay, so in this first example, we've got two functions, t of x and r of x. All right, so I need to find r minus t of x. So what that means is first take r of x, and then you just subtract t of x. Okay, so when you're adding or subtracting functions, you can just take them separately and add or subtract them. Okay, so we would just take r of x, which is x squared plus 3, and then we subtract t of x, which is x plus 4, but we need to subtract that entire t of x, and so we'll distribute that negative. And we end up getting x squared plus 3 minus x minus 4, and then we can just clean that up a tiny bit, x squared minus x, and then combine our numbers there. We'd get minus 1. And there's our final simplified expression. All right, let's look at r divided by t of x. So we would take r of x and then divide it by t of x. Okay, so here we go. This is equal to r of x is x squared plus 3, and then we have t of x is x plus 4. And there's no simplifying I can do there, so that actually is done. And multiplication, we would just take t of x and then just multiply it times whatever you get when you simplify r of x. Okay, here we go. Let's see, t of x is x plus 4, and r of x is x squared plus 3. So there's no simplifying in either of those, so we'll just go ahead and distribute. We get x cubed, and then distributing our x to the 3, we'd get 3x, and then distributing the 4 to x squared, we'd get 4x squared, and finally plus 12. And we could write that in descending order. All right, and that is done. Okay, so there you go. You just do your algebra on each of those, and just be careful here on a, with a division, there would be a domain restriction there. X cannot equal 4. All right, when we're composing functions, this is written f of g of x. Both of these ways of writing that are identical. And the way we do this is we will take and put our input for f is going to be whatever we get out of g of x. So there's g of x, and now that's going to be what we input into the f of x function. Okay, so here's our f of x function. Okay, first we got our g of x, so that's your output for g of x, and now that's going to go in to f of x. Okay, so every time I meet an x in f of x, I'm going to replace it with 5x plus 4. Okay, so let's see how that works. We'd get 5x plus 4, and then that needs to be squared from right here, and then we say minus 3 times x, but now our input is 5x plus 4, and then plus 1. So that whole thing is f of x, and now we need to simplify it. So we'd get 5x plus 4 squared, so you have to multiply that times itself. And then distributing your negative 3, we would get negative 15x minus 12, and then copy down that plus 1. So we get 25x squared when we're distributing here, and then plus 20x plus another 20x, so that'd be plus 40x plus 16, and then copy everything else down. And then I'm just going to clean this up. I've got 25x squared, combining like terms. Let's see, what do I have for x's? So 40 minus 15, that would be plus 25x. And then looking at just my numbers here, 16 minus 12 is 4, and then plus 1, that would give us plus 5. And that's how you compose functions. Let's try another one. So here I'm going to take, and my input into g is going to be f of x. It's going to be my output from f of x, okay? So here we go. F of x is x squared minus 3x plus 1, okay? So that's what I'm going to input into my g function. My g function is 5x plus 4. But instead of x, I have now x squared minus 3x plus 1. And then just copy that plus 4. Okay, so there's my g of x function, and now I need to simplify that. I'm going to distribute that 5, so I would get 5x squared minus 15x plus 5, and then plus 4. And final answer there, 5x squared minus 15x plus 9. Okay, so one function's output becomes the input for your other function. Okay, we're going to try another one. All right, let's try another one. So we have f of g of 9. With the number here, I'm going to actually figure out what is that output. So I'm going to figure that out. G of 9. Okay, let's see, what would we get here? G function takes 2 times x, which is 9, minus 8. So I would have 18 minus 8, which is 10. All right, now I need to take the, I need to input that 10 into my f of x. Okay, so here we go. F of x takes 3 divided by x, which I'm replacing with 10 minus 4. So that'd be 3 over 6, which is 1/2, and that's done. And I've got one more, g of f of 6. Okay, so first let's figure out our f of 6. Okay, so f function takes 3 divided by x minus 4, so 6 minus 4. That would be 3 over 2. All right, so that's now going to be what we input into g. So g of 3 over 2 is, let's see, the g function takes 2 times x, so 2 times 3 halves, and then minus 8. So I would get, multiplying straight across 6 halves, that simplifies to 3, minus 8, so we'd have negative 5. And that is done. Okay, we were estimating functions and doing composite functions using algebra. Now we're going to do this graphically. So if I have subtraction, this means f of 3 minus g of 3. Okay, so let's figure out our f of 3. My x is 3, so I go up to my f function and I figure out what's the corresponding y value there. So that is an ordered pair. That is the ordered pair 3, 4. So the output, the y value there is 4. So f of 3's output is 4. And let's do the same thing for g of x. So I go over when x is 3 and I go find my g of x. All right, and that is an ordered pair. And what's the y value there? Well, let's see, 1, 2, 3. It looks like it's 3. Okay, so our y value, when your x is 3, the y value that corresponds to that spot on the graph for g is, the graph of g is 3. Okay, so that ends up just being 4 minus 3, which is 1. And here I can take and evaluate g of negative 2 and then divide that by f of negative 2. And let's go and figure out what the output is from the g function. G function is down here, so that's an ordered pair, negative 2, that's negative 4. So the output when x is 2, the y value there is negative 4. And we do the same thing here with f, and that is the ordered pair negative 2, and the y value there is positive 2. Okay, so when I go to my f function and I look to see when I put in an x value of negative 2, the output there, the y value is 2. And then I can simplify that fraction, and there is g divided by f of 2. Okay, now I've got composite functions, so what this really means is g of f of 1. So first I need to go in and evaluate f of 1, and then I'll plug that in as my new input for g of x. Okay, so we go to where the x value is 1. We need to find that spot on the f graph. So the y value there is 2. Okay, and so now I go and evaluate g when my input is 2. Alright, here's 2. So I go up to that spot on my graph, which is right here, and that y value at that point is 4. Okay, one more. I'm going to take and f of g of negative 3. Okay, so let's first figure out g of negative 3. Negative 1, 2, 3. And the g, let's see, that's the red one, so we go down here. Looks like that y value is negative 4. And so now that's what I'm going to input into f. And here's negative 4, and it looks like that would correspond to this little spot right here on the f graph, and that is the ordered pair. The y value there looks like it's at 2. Oh, actually negative 2, right? Okay, so our output is negative 2. And we are done.